that we can move content out. All right, so object-oriented programming. So you're going to see that term a lot. It's not going away. It's an idea that is coming to maturity. And so it really is kind of a different way of thinking with things. So when I first got a computer and we looked at it, everything was putting things in lines of code, and each individual thing had to do every item on there. And so as programming languages have got more advanced, we've started to be able to break things into these kind of black box ideas. And that's what we're creating, is this idea of we pass in information and we create these groups, and we call them in a lot of cases classes of objects, and they can inherit ideas and inherit properties and inherit even things that they can do, or something we're going to call methods. So no longer do we have to, if I'm going to create a program, do I have to create in a completely new item for everything? I get to do the idea of I can create a class. So on page 219, they talk about object-oriented basics. And so make sure you have read that. So objects really now are becoming something almost, I don't want to use the term self-aware because they're not self-aware, but they are an object. So you can think of it like a person. They have characteristics. They have attributes. So each object that we're going to talk about has things about it. So we can talk about, if we talk about a person as a class, all people have some very similar things. They have a sex, they have eye color, they have hair color, or in some of our cases, lack of hair color because we don't have any hair. So we have these attributes we can assign to them. We have methods, those things that they can do. So we can teach, we can listen, we can learn. Those are all attributes we can do. And when we create them as a class inside of that computer, then we can get it to do things. And we don't have to create individual new lines of code. We can actually create multiple copies of the same class. So think about if I'm creating a human resource program, and each time we add a new employee, I had to rewrite a whole section of code to include that employee. Well, that's not very user-friendly. But if I had a class that said employee, all those attributes, each time they work in there, get attributed to them, and we create an object for each employee that we create. And so maybe it'll become a little more clear. I know this object-oriented program is one of those odd things that's hard to wrap your head around until we actually do some examples of it, I think is probably the easiest way. So on page 220, we're going to create our very first object. And I will say, if you don't work through these, you are going to be lost. You really do need to work through on this particular items. So we're going to create a basic class. Now, one of the weird things, until we actually create an object, nothing exists. We create the framework for it, but nothing exists until we actually create an object from a class. So let's define our object. So I'm going to open up an idle window here. Somewhere I have one open. Or maybe not. Somewhere I have a blank one. All right. So I'm going to do File New, create my new blank workbook here. And I'm going to define, again, make sure your names are on there. I did see a couple of assignments that slipped in that didn't have comments and names, and it makes it really hard to do any grading or anything on that when I don't even know whose it is. So I have to go back and try to figure out where that particular item came from. So we're going to create our first object. And remember, everything in here is really designed around the idea of games. In this particular book, or this author likes that idea. So think of that maybe that Space Invaders, where each one of those little critters up there that's coming down to try to kill you is going to be an object we're going to create. So we do something called class. just like when we defined a function, we tend to use an uppercase. So on page 221, defining a class. So when we define this class called critter, so by default, we tend to use capital letters to say that that is going to be an object. Not on the entire thing, it's not a constant, but we'll use an uppercase. It's not required. Python doesn't care if we do it all uppercase, lowercase, whatever we did. We can actually do that. So we're going to base that on something called an object. So this is built into Python. So we already get some things in there. So once again, it's a colon, and that tab in is how we start to block this. And so when I've started looking at the homework for last week, one of the things I saw a lot of people not do is didn't do proper indents. And so we'll go over some of that homework and look at some of the pieces that I saw. But remember, everything inside of Python is based on those indents. So if it's at that same indent level, it's considered a block, and it will do something. So I'm going to actually define then inside of here, I'm going to define something it does. And I'm going to define it as talk. So we're going to create a method inside of this class. So the method is what it does. And we're going to reference self. And when we call this particular method, it's going to print out and introduce itself. Hi, my name is blank. I am an instance of the class critter. So the other thing our book shows you is that you can use those triple quotes again. It's not a bad way to say, hey, this is a virtual pet, for example, is what they use as an example. It's a nice way to do that. You can also use same thing. We get a lot of information out of that. By default, we tend to use these triple quotes just to introduce it, so we have a very quick idea, and then we'll do details then inside of the comment tags like this. So there's not a lot to this particular object. We called it, we introduce it, and until we actually do something with it, so here we have our main, and much like everything we do at this point, we're going to have our main in a block of code. Notice we don't have anything else. We don't have any randoms or anything else. We're just doing a very basic program here. And we're going to say crit is assigned the value of critter. Now we don't pass anything into it at this point. All it does is call that function critter. And when it runs, it only has one thing at this point. It has a method called talk. And so let's see what happens if I actually save this. Where am I saving it? That doesn't matter. And we go, well, oh, nothing happened. All right. So we defined it, but we haven't made it do anything yet. And so we've got an example of it, so now we need to actually make it do something. And that's where we use, and notice it even pops up crit.talk. We're not passing anything into it. and goes, hey, my name is blank. So we're not limited, though. Let me show you this. Is we made one copy of that object. And so I could call that crit 2, 3, 4. So now I've created 4 copies of that. They don't do anything other than create a copy of themselves. And now if I did the same thing to call that function, to call the method in there that actually does something. So crit1, crit2, crit3. And essentially we can create unlimited numbers of these objects. And we're going to show you how we can do some more pieces with them. So right now it says we created 4, and I had 4 of them actually call their method or a method that's inside of there. So there's a couple of things in here we're just going to have to take on faith for now. And one of those is this piece here on this where it says self. That references back to its own object. And we know that. We're just going to take that for on faith right now. So 222 talks about instantiating. So in other words, when we create an object, we do something called instantiate. So that's this line here. We invoked a method that's inside of there right here. Well, we can do a special type. We can do a special type of instantiator called a constructor. And so at the bottom of page 222, it talks about something called a constructor. And a constructor gives us the ability for when we create this program for it to do something on its own. So we're going to define it a little differently. I'm going to leave this alone, but where we have this talk function, we're going to change that. And if you look at it, it's 2 underline spaces, INIT, underline, underline. So that is kind of an oddity. And so in this case, when this runs, it should do this on its own. So we're going to take those out for now. And I've got something I did wrong somewhere in here. What have I done? Doop, 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 doop. Underscore, underscore, self. Space between which one? Yep, there you go. Glad you can see that. I am looking through squinty little itchy watery eyes today, which makes it more fun. I love allergies. So now we run this, and in theory, let's see what happens. Oh, I didn't do anything other than create it, and it actually runs this. So this is a way to run something the minute we construct an object. That talk feature can still work. So if we use that talk feature, we'd have something very similar. We could use that, but this says every time we create it, automatically whatever's in here is going to run. So whether it's a print statement, whether it's a statement that does an action, that constructor is our way to have it happen automatically as soon as we create a copy of anything. So we can call a method inside of there. So we can use that constructor. So there are a lot of these kinds of things. So those underscores, you're going to see a lot in Python code. You'll also see it in some other languages, Ruby on Rails, for example. It's a way we say here it's something special. So don't be surprised if you see that again. So we actually jumped ahead on 224. We constructed multiple objects. We did that. We made that happen. On page 225, we're going to start creating some new objects and add some attributes to this. So we're going to take our code and we're going to modify it a little bit. And we're still going to create something called critter. And we're still going to have a constructor, but we're going to add another piece to it. And we're going to add name. And name doesn't mean anything. It's just a variable, so don't get hung up on that. I have had some students do that. So I'm going to change this just slightly. And I'm actually going to change it to, just so we can differentiate between it and the talk function. A new critter has been created. A new critter. Yeah. So we're going to give it a name. And so we're going to say self.name equals name. Now, that seems a little odd, but hang on and we'll work on what we're looking at here. So when we do this, we want to be able to give it a value back into this object here. So on page 220, somewhere around 225, we're creating this new object and we're going to be able to pass it in a name. And so we'd like to be able to access that name, be handy. So we're going to do a couple of different things. So we're going to have our constructor here. We're also going to define another method. And once again, it's kind of an odd one. So it's a string method. So all right, so let's take a look at a couple of things here. So what we're doing is this function is we're going to create a function that we can output its own name. So we're going to give it a name and we want to create a way that we can output it. So here we've got a function that says rep equals critter object, all right, and then it's that plus name, it's self name, so whatever we pass in here, and then we need to return that. We created a temporary variable called rep. We're going to return rep back. So let's do a little bit of experimenting with this. So I'm going to get rid of my main right now temporarily. And we're going to call crit1 equals critter. And we're going to pass it in and name. And so if I run this now, save it. All right, the constructor works, and that lets us know that, hey, we really did create a new function or a new object name, in this case, Mark. So this piece ran. We haven't actually called this function yet, but we can. So we need to also create one more piece in here, and we need our talk function back. So talk, and so here we could say, hi, and then self.name, because we had that handy item we created. And then we just put a new line so we make sure it hammers it down one line. And so now if we said crit1 dot talk, it should, oh, look at that, it can actually print out its own name. What do you mean it's not running? There's nothing in here that shouldn't run on any version of that. So I would look very carefully. What error are you getting? So you've got actually an error up here in here somewhere. All right. So in this particular case, so now we've got a critter that can talk to us, and it doesn't have a whole lot. It's got a name, but we're starting to add more and more abilities and features into that. So we can also do some other things with it. So we can assign a second one just to make sure. So I'm going to copy and paste. And I'm going to call this one crit2, being very original. And I'm going to send it in a new name called Ann. And I want to see if we can actually end up with two critters. And it says, hey, a new critter. So we actually have two independent objects in there now. One called Mark, one called Ann. So we can add them, give them names and some attributes. So the talk method works. We constructed this talk function. Well, let's see what happens. What happens if I just try to print crit2? So, oh, well, that's interesting. So here's what we did. We called it, and it says, hi, I'm Mark. Hi, I'm Ann. Critter object name Ann. So if we just try to print it, it shows some of the information that's inside of there. Now, that's probably not useful in terms of I want to be able to utilize that information because that's kind of an awkward format, but it's a great troubleshooting technique. So I could put that in and go, I'm just not sure what's really what this object has got for attributes, and so it's a great way we can do that. We can also do, so not only can we print it that way, crit1 dot talk or name. So we know that attribute in there is called name. We can access it directly, that dotted notation. So that way we can actually reference it right away. So we could have down here, if you really wanted to, print hi, my name is Mark, because it's pulling it right out of that object that it's created. And we don't have to go through any other routine. We can actually just use that dot notation. So those attributes are kind of an interesting way to get inside of there. So page 228 at the very top, they've got this hint function. So it's handy. It breaks some of the rules that we're going to talk about a little later when we talk about like functions where we wanted them encapsulated. If I'm inside of the function or inside a module that's using that function, it's okay. I don't want to do it as an entire methodology, because if I can access it from anywhere in the program, that's not necessarily good. So we have a couple of other things we need to look at. And so we're going to look at one called the Classy Critter program. So we're going to start on page 229. It really doesn't start until 230, but we're going to create something called a Classy Critter. So I'm going to take this and do a new. So we're going to use some of the same things we've done, but we're going to create an entirely new critter. And we're going to call this one Classy Critter. So and we're going to talk about some other pieces in here. So we're going to create our class. Critter. So, and again, we're going to use that built-in object. And we can give it a non-shedding. All right. The first piece in here we're going to do is we're actually going to put in an attribute for the entire class. And we're going to call this one total. So if I tried to run that and look at total, so before we do any other thing inside of this particular thing, I'm going to put in my main. And I'm going to call crit1 So in theory, we've just created a class called critter, and I want to see if I can print total. So what I want to see is if this value inside this class, we instantiated it, right? Can I see it? And so I'm going to call this classy. Oh, hang on. Not the error I wanted, but all right. So if I run this, it's going to give me, and that's the error I was hoping to see. Total is not defined. So total, we've created something that's locked inside of this class, and we can use it inside this class, but it's not something we can directly access. And that's actually a good thing. So we're going to put in a few more pieces in here. So we can do it inside of here, but we can't do it from external yet. and we'll show you how we can get to that. So we're also going to do something here, and we're going to introduce a whole new symbol. So at static method. So this is something a little different. So we're going to show you what that will do. And notice it even gives us a kind of an interesting color here. So must be something. It's got a purple color to it. And we're going to define status. Print. Move it down a line. The total number of critters is, and then we're going to do, be helpful if I capitalize that, critter.total. So now we can keep track of how many critters we're creating, which might be an interesting thing to do. We have another function, so we have our constructor, init. So that initial means that whatever we're going to do here is going to run. So self, and we're going to pass in a name. We're going to have a familiar, a critter self.name equals name. So this is the step where we pass that name that you sent in and we assign it to self.name. And then we're going to do critter.total equals critter.total plus 1. Now the book shows a shortcut and the plus equals thing, but honestly it just has, in my brain this makes sense. We take the original critter total, add 1, and pass it into critter total again. So that makes sense in my brain, may not make sense in anybody else's. So we can get to this in a little different function. So print and so using our, I'll end that one. All right, so print, before it errors on me, print. And now we can use the critter.total, and we can see if we can get that value as it runs. So right now, it should say 0. Well, that makes sense. That makes sense. However, if I did up before that, critter, we'll give this one a name of Bertha. I'm trying to come up with names. Hang with me there. All right, now it says, hey, there's 1. And so if I did critter1, critter2, and now I run it. Hey, now we get 2. So we're able to do some functions inside of there, which are kind of interesting because every time that constructor runs, it adds a 1 for that total number of values. So we could, in theory, create an unlimited number of these. So this method gives us a way we can bring data in and out. So everything else we've done still works. So if we added the CritTalk feature in there, we could still do that. So this just gives us a way that we can actually pull that in there every time we do that. So we could do some other wave functions with it. We could do some other things. So if I did, so we got to it directly. What if we ran critter.status? So in other words, we're running another piece there. We're not passing anything into it, so we're not creating a new object. And so the total, getting to the total of critters, we have 2. And here it takes the total number of critters is, and I could clean that up so it looked a little better. But it's able to access that inside of there also. So F5. The total number of critters is 2. So anytime we want to find that value, we could just use the critter.status. So let's see what happens if we add another piece in here. So critter.status seemed to work. What if we did, let's see what crit1 does, just as a remembrance. So if I run that, oh, yikes. That's pretty ugly. That doesn't help us a whole lot, does it? So it gives us some information about it. What it's actually showing here is the hexadecimal address of where that object is stored at. Yuck. Not useful right this minute, but shows some of the stuff that we can get out of there. But what if we do critter1.total? Can we get a function out of that? And when we do that, it does actually call that number 2. So we have multiple ways to get at that data that's stored inside of there. So on page 232, we look at the idea of encapsulation. So encapsulation is as we start talking more and more about security and safety, and encapsulation is one of those tools we use to try to protect data. And so whether that data is credit card numbers or whether in this case it's a tiny little critter, it's all that idea of, if I do this correctly, this information is only accessible inside of this particular class. So we're going to look at one that introduces us to the idea of private methods. So I'm going to do a brand new one again, just because I like typing. Move it on over. So this one we're going to call private. Just so I have my name in there and I know it's in there. So on page 234, we start getting a couple of things we're gonna look at. So once again, we're gonna create class critter. and it's of the type object. This time, though, we're going to do an instantiator or a constructor, NIT. This time, though, we're going to have self, name, and another one called mod. So we're actually going to have 3 pieces to this particular one. So we're getting a little more complicated, adding some pieces. And we're going to print and we're going to add self.name equals name. So in other words, whatever we pass in as a name. And I'm going to call that my public. We're also going to have one self.mood. And notice I put the 2 underlines in front of it. And we're going to call this one private. So those underscores in this case are that key to Python that says, you know what? You're doing something, but this particular piece of data is going to be what we call private. And it's that underscores that give us that clue. All right, so we're going to put our talk function back in. So we're going to put a talk in there. And we're going to print out, hi, I am self.name. And we're going to have another print statement that says, right now I feel like and then we're going to access self.mood. All right. So from inside this create function, main, so we're going to create a new critter. All the way back would be good. So we're going to call it crit1, very original. And so now we have a few other things to put in there. And so we're going to do a couple of things. So we could just do, what did we do last? C, so D, so Donna. And we could put in the mood of all right, and we could do that. We could pass in items that way. But we can also do something kind of interesting. So since we know we're going to put this one as name, we could actually add this key phrase, name equals, and you could say mood equals. So it makes it a little easier to do in terms of understanding, especially if you have a lot of things you're passing in. It targets it, and you could even put them in opposite order. So you could actually put mood equals sad and flip those around, and it's now going to assign it to the appropriate place. So I'm going to run this one, and we're going to call it private. On which one? Where up? Oop, oop. Second time. Oh, got it. All right, so let's try that again. All right, so it does. It says a new private critter has been born. All right, well, let's try to access that talk function then and see what happens when we actually try to access that. So we're going to print crit, what do we call it, crit1, yep. And we're going to try dot underscore mood and see what happens. Oh. But wait, we created it, right? Why is it giving us an error that says, oh, didn't want to do that. So why is it saying there isn't one called mood? Yep. So if you think that that would make a difference? So let's try it. So if we put in self.mood, so you think you need to do it like this? We can try. I'm just trying to get the value of mood back out of it because we passed it in. I'm just trying to figure out how we can get that mood back out of it. Is there an easy way to do that? Oh. So what happens if we do this one? What if we call crit1 equals sad? Okay. So we created this critter, and we know if we do that, it reports back and says, oh, private critter's been born. So we've used that method before, crit.talk. So let's see what happens there. That should run this function there, right? Oh, probably helpful. All right. Oh, hi, I'm Donna. Right now I feel like sad. Weird wording I had in there, but right now I feel sad. Okay, so we can access it by calling it in here. Let's try see what happens. Gosh darn it. If I'd remember to put the 1 in there, it would be really helpful. Oh. So we may need to add a public method if we tried to use that method. So private methods are kind of handy. So we get a lot of details out of it. And we can hide them because I can't necessarily get to this easily and quickly. And that's good. I don't want to be able to get to it. So we created a private method. So page 236 talks about accessing private methods. So there are ways to work around it, but generally we kind of say, no, let's not. So if I do this is not necessarily the strongest self-defense that you can have in a program, but it gives you that idea of we can hide things when we need to. So for example, this is a good idea. We might say name is available, but mood, maybe that's not so available. Or self dot social security number. So we might want those kinds of things set private. Now again, this is not the end all of security, but it's setting that idea that we can have things that are accessible outside of the method and inside of the method. The easiest way to access this, from inside here, I can access it without any problem at all. So as long as I'm inside of this, or I call a method to deal with it, it would work really well. So I could do crit my social number is Social Security. And you could do it that way and suddenly pass that out. And so in this case, we'd need to add and so we could add that value in there. On here, you could actually pass it in this way because you're actually saying name, mood, and social security number. We don't, this is just an easier kind of a identifies exactly, because at this point we're passing in really 3 different things. If we were passing in more, it's kind of a handy way to identify that. The other place it comes in very handy, we don't normally pass in a name directly. It's going to be another variable. So if I'm passing in name equals X, that might identify and let me know what it is. Because a lot of times we'll have a variable in there that we don't know what it is. So we're trying to introduce you to some really odd things in here. So there is one last program we'll look at here really quickly. We probably won't get it all done today. We'll finish up on Thursday with that and also talk about the homework. There is one called property critter. So property critter, let me clear out some of this junk here. Junk, junk, junk. Did I get enough of it out of the way? Here we go. All right. So I'm going to look at property critter, and I want a new one. Ooh. Come back to the right window. All right. So this one we're going to call property. And so we're going to do a couple of things we've done before. We're going to introduce our new class. We're going to call it critter. There's a surprise. And in this particular case, we're going to do a constructor. And we're going to pass into this particular one self and name. So no mood, no nothing else. And we're going to say print a new critter has been born. So nothing unusual yet. Now this looks a little different. It looks like we're putting the name as a private value. Okay. So we're going to put the name as a separate value. And we're also going to then put something new that we haven't seen. So at property. And we're going to define name and that's going to be return self dot name. So the general thing we're do with that, so this at property thing tells us that we're going to create a property called name, and when we call this function, it's going to return that private method. So I can't just put self.name down in my main program and return it. I have to do it through the program. So we're going to do another one called at name.setter. So this one, so it's going to take in self and our new name. So we can actually change that value. So if new name is equal to blank, cannot be blank, else self dot underscore name is equal to new name, and you could print out congratulations, you got a new name. So we have a few other things we're going to put in there. So nothing unusual now after this, really. So our talk is still very similar. So we're going to define talk. So we're just going to create a method to do that. And that talk really just says print, hi, my name is self.name. So now we're going to create our main. And we're going to create a critter. DEF, so fauna. Talk. Somewhere I'm missing something. Yep, there it is right there. All right. So in this case, a new critter has been born. So again, we created a instantiator constructor, and we made it run and said, hi, my name is Fauna. Okay. So we found the self-talk function. What's interesting, self.name, now notice here, we called that an underscore. So we need to look at that a little bit and figure out how that works. And then we need to create this function so we can actually change the name of a critter on the fly. So make sure you have worked your way through this week's assignment, which I don't have up.